Hi guys, here is a demo of how to use FlatCam. So I'll start low create a project, say new project, and I usually save the project to start with. So save project, and that will in this case will be in this folder PC projects, and the one I'm going to use is 8-bit Gerber. And so in this case I will start there and we'll save it here. So it will be you can give any name, but I just choose to have the date and then the name of the project, even though the file name is of course the same, but never mind. Okay, so now we save the project, and during the demo I will also save the project several times if we don't lose our job. So we'll start with loading the Gerber files. So this one is the Gerber file opening, and within this we need to go back to the other folder as well, and there was keyboard 8-bit, and in this Gerber folder. So the files with a program FlatCam are the Gerber files. So in this case we have bottom side of the PCB, and we should also have the top side of the PCB. So it's the keyboard V3 top and keyboard V3 bot. So let's take the bottom side. Right. So the file is loaded fine. Now we go and select the bottom side, and in this case it will be the keyboard V top. Oh sorry, we have already done the bottom side, so now it's the top side. So we got both on top of each other, both sides. And the next one is the drill holes, and this is the keyboard drill. So this is of course the only one side, but I normally use from the both sides, because if you drill all the way, the very small drill bits tend to turn a little bit, and the holes are not straight, even though it's a very thin board. I think it's 0.75 millimeter thick, but still. So what we do is we will load the normal drill board, and that could be, that's in the bottom side. So all the drill holes are come out fine, and you can also see the difference in the sizes. I think this is a 1 millimeter, this is probably 0.6. These are the wire holes, and then the touch button are 0.9 millimeter, and these are probably 3 millimeter. Okay, so let's take the next from the drill hole for the top side, and they will be again use the drill. It's the same file, just load it twice. This is not necessary, but I find it good, because then you have a straight holes and there are no burrs on the other side if you drill from the one side, you'll probably get uneven and burrs on the other side. So this way you have a good quality of drill holes. All right, so we have that. Now we can't see because they are just top of each other, and the name on goes different. That's a drill, and then drill underscore 1. So as now that we have this, we are going to create for the both sides. So we need to sort of turn one side of the board, because in the reality on the CNC machine you will also be turning down or up, whichever side you try to engrave first. So let's see. Okay, this icon will give you the two-sided. So will the bottom side we'll use is the bottom, and also select the same and drill file, and okay, and so we now have to select whether we are rotating on the x-axis or the y-axis. So this is, yeah, up to you, whichever way you want it to turn around. So let's say we turn around on the x-axis. So when you turn around, this side will be up, and this top side will be down. And the y-axis, then you will have this side on the right side, and this side on the left side, likewise. Okay, so we'll then have references out of the box, and reference object is of course this one, the keyboard bottom side. That's what we selected up there. And now create the right, and what am I missing here? Okay, so we'll just mirror the bottom and the track side of it, and now the drill. Okay, so we can see now the drills are, yeah, the bottom one are showing as well, and the top one, so they are stacked on top of each other. So next one we're going to have is, so finish with this one. So now we go back to the project, and and we'll select the, we can hide the top side just to be clear, and that is disable plot, and the same goes for the drill side also disable that. So we only got the bottom tracks as the engraving tracks, as well as the holes, drill holes. So let's select the engraving part, and let's click on selected. So here we're going to click on isolation routing. So I'm going to use a V-shape it has a almost a zero tip size, and let's see if it's a 0.1 millimeter the tip size, and it is a V shape. Okay, and the angle is 30 millimeters, so we leave as it is, and the depth of it on the copper clad is about 0.35 millimeter. So just to get a little bit more out of it, we'll just say 0.035 is the thickness of the copper. So we just say that is we're going to engrave 0.05. It's about 0.015 millimeter more than the copper clad. So we get rid of everything, and still we almost not touching the fiberglass at all. It would be a little bit, but 0.015 is very, very little, so you won't really see it. And we're going to create 3 passes so we get a clear, and then overlapping I will give it a 25. And we're going to combine those so the 3 engraving cycles are in one file. Otherwise it will produce 3 files, and you don't really want that. Okay, so we got everything set up. Now we create the isolation geometry. There you go. So this is how it's going to, if we zoom a little bit, so you can see these are sort of 3 passes with the overlap of 0.2 25%, 15% overlap. Or was it? No, 25% overlap. Okay, and so here is more visual that these are these 3 tracks is going to engrave. So that should have enough distance, or the proper distance. I find it 1 or 2 are not sufficient, so therefore 3 or more if you wanted to wait a little bit more to get a better quality. You can of course get 1, but the thing is, because it's a V-bit and I'm not going deep in the board, so therefore it's a good idea to have 3 iterations on that one. Okay, and so you've got this one, and now we want to generate the CNC job. And in the CNC job, we've got our engraving bit, which has a diameter of 0.1 millimeter, and that's again the same as the cut depth will be minus 0.05 millimeter. You can do a multi-depth, but since the depth is so little, I don't think it's a good idea. We won't get anything out of it. Having a multi-depth, then we will end up having 6 iterations rather than 3. So we'll leave it single depth, and then Z travel will be 2, or you can also have a 1 millimeter when it's lift up to move from one place to the other. Feed rate 120. This is dependent on your machine, but mine is set to 120 on X, Y, and Z. Feed rate is 60. I can go a little bit more, but that should be enough. And spindle speed if it's a manual spindle speed, you don't need to put anything, but if you have a controlled spindle speed by the software, then yeah, put the speed in at 15,000. Should be sufficient. The valve is, and when it comes down, it will just stay there for a second before it moves on. So maybe it's stabilizing factor. And then that's about it. I don't have any tool changer, so I don't need to do anything there. So generate the CNC job. So then the blue one are the actual cutting tracks when it's done. So this it has taken the thickness and the overlapping in account, and therefore you have a full thick lines rather than the three small thin lines as we saw on the geometry. So this is basically following the same geometry, but just showing us the actual tracking how it will cut. So you probably won't see this thin line there. If we zoom to the actual size, then you see this is continuous line. So green inside the are the actual copper. So that's about it. And so you got the that part, so let's save it. So I'd like to save it to a separate folder, just to avoid too many files in one folder. So let's say new folder CNC1 _1, because I already have one CNC there. Okay, so going to save the keyboard V3 bottom side ISO combined CNC. So these and the NC is the actual the Gcode file type. So save this one. So now we need to go back and do the drill bits, and so we select this is the drill one, select and come into selected. So we have all the 6 sizes, so 0.6 millimeter, 0.8, I think I said about 0.9, but it's 8. And then we have 1 millimeter and 3.1 millimeter are the mounting holes. Right, so Z cut here, it actually recommends 1.7 because, but since we are going to do it on the both side, so I will do that. It will be 0.800. So that will be from the bottom side. Soon after we will engrave, or we can also start with drill holes, and then here we can use the multi-depth. So let's see. So if we say that we are going to have let's say 0.4, so it will just drill twice, and so then it shouldn't sort of what you call it, the drill bit wouldn't bend, because it has tendency to bend slightly because the copper side and the fiberglass are quite hard. And then drill bits, so 0.6 is a very thin drill bit, so therefore it's a good idea to take it a bit slowly. And then the travel Z is the same as before. Feed rate, probably have it about 150 and not too sort of do excessive force on the bit, tiny bit, and 15,000 the spindle speed, and then the dwell is 1 second. So when it goes to the bottom, it stay there for a second, and that will sort of give you a clean hole, I believe. Okay, so we don't have any tool changer, so that's about it. And then generate. So we've generated all the drill holes, and these two boxes you can specify if there are any additional G-code initialization you wanted to have, and the same at the end of the program if you wanted to have any other specific to your machine, which this program may not create it because this is a generic program. So if you wanted to have a specific one, then you can specify those in there. You can also specify those in the ini file, so you don't have to do that every time. Okay, so let's save the file. So we go again into CNC1, and we'll just say the drill instead of CNC, because we know it's drill CNC, so we will just do a bot. So this is from the bottom side, and save it. The next one is we go to the here. Now we can hide the bottom side, and the same goes for the drill, and also the geometry for the previous one. And we can also sort of hide everything in one go. I just wanted to go through it one by one to show you. Okay, and so now we enable the top one. Top, and the same goes for the drill. Yeah, so that's about it. And so let's go back. Okay, so we'll select the track engraving part, so the Gerber part, and then here again go through the same thing. 0.1, 0. Z cut is 0.05, and so and passes. We had 3. Go ahead, and it's 15% overlap, full, and then combine. So we got all 3 in one file. So generate the isolation file, and then we have so isolation file is generated. So let's go back again now to, and so this is the newly created isolation file. Select. So now we can create the G-code for them. So tool size is the same. It's not going to change anything. Same as here. Spindle speed 15,000. 15,000. And that's about it. Generate CNC job object. Sure, here you go. So similar like before, and then save the file. So the file is fine. So we just go into CNC2, and this is the keyboard top ISO combined CNC. And that's it. So now what we got to do is yeah, drill site. So this is the top drill. Select there, same, because it should be the same hole size and everything. Apart from this, so 0.8000, and the depths in here we can have multi depths. So that will be, oh, what did I do? Four, and all right. Okay, we've got those. Spindle speed, and we used this 15,000, and dwell is 1 second, and everything else is fine. So now we got our drill hole file, so save the file. So this time we need to actually say, instead of 1, we could probably say that it's a drill top, fancy, and we are in the CNC one, yeah. So we will save all 4 files. So what's left is now, if we say this one, select it and cut out, so the board cut out. So tool diameter, yeah, the 2.54 will be fine, but I normally have 1.4 to cut the board out. So Z code would be probably minus 1.2. You do have the possibility to cut from both sides if you wanted to, but it's fine. And multi-depth, so this will be about, this is 1.4, so we can say, so the cut depth is 1.2. So if we say 4, so it will have a 3 go cycles to cut the board, and margin is 0.1, so that's okay. And gaps 4, so these gaps are for holding the board, so we can then cut the board out, otherwise the board will be sort of moving during the cutting side. And generate the freeform rectangular, yeah. So these will be the tabs, and the board is still held in there. Once they finish, then we can just pop the board out. Okay, and then generate. Okay, geometry is generated now. So let's go out, and then this is the top. Oh. Yeah, so it's cut out, and then select here, So tool diameter 1.4 and the depth will be minus 1.2 and then 4 cycles, 0.4 millimeter on each cycle, and spindle speed 15,000, and keep it the 1 second as it goes into the board, and then generate the CNC job object. So you see that's the board cut out, and these are the tabs. So it will just cut from here to there, pop up, and then go here, and then likewise. Yep, and then we can save. And this CNC one, sorry, cut out. Sorry, we just selected the wool cut out from the top side. Doesn't really matter. It will be the same whichever side you do it from. Okay, and now we can save the project, just if we have to come back and do any changes later on or add into the project. So save project. So we have all the settings there. Now just to show you, I'll just minimize this one. This is the actual PCB layout which I created the Gerber file from, and what we wanted to see was the PCCNC, just to show you how it's going to look like on the CNC. And that's the one. No. Oh yeah, there is. Okay, so we just open one of the file, and we are in CNC 1. So we say the ISO combined the bottom side. Okay, so here it is. This is how it will look like when the CNC machine started to engrave. So as you can see, these are 3. Well, here it shows you 4, but it's actually 6 here, because one of them is on top of each other. You see here 1, 2, and 3 there. So that's how it looks like. This is the bottom side. Let's take the drill holes, or maybe the cutout, and the cutout side. So this is basically 3 cycles to cut the board. And if you just take the last one, is just one side of the holes, drill holes. So we can take bottom one. So these are all the drill holes. We will only show the same size, but depending on the drill and the bit actually, because it's just showing the center of the drills. Yep, that's not it. I think this is okay for today. And